Lesson 2.3 is all about simplifying variable expressions. Now, variable expressions are ones that have variables and sometimes some numbers with them too. Something like 4x plus 3x, that's a variable expression. Why? Because of the x's, they're variables. Now, the parts of an expression are called terms. So this 4x, this is one term. The 3x is another term. Okay, and what we're allowed to do is simplify these expressions by putting together what's called the like terms. Now, like terms have the same variable in them. So, for instance, 4x and 3x, those are like terms because they have x's. So what we're allowed to do is take 4x and add it to the 3x and get a 7x. So just like our little explanation here says, the 4 and the 3 are called the coefficients, and we're allowed to add those together. Now, let's really talk about coefficients. If up here are coefficients 4 and 3, what are the coefficients in 5x and negative 2x? Well, the coefficients are 5 and, I don't know why I put that comma there, and 2. Okay, sometimes we may even have numbers in our variable expressions that kind of look like coefficients, but they don't have any variables. These are called constants because they have no variable to change the value. Notice up here in my 5x, depending on what x is, this whole value here could change. If it's 2, this is 10. But if this is 6, this is 30. It's just different depending on what x is. But if there's no variable with the number to change it, it's constantly that number. So in 6x plus 2y plus 5, notice how there's nothing here with the 5. The 5 will always be a 5 no matter what x and y are. The 5 will constantly be 5. All right, let's do some identification here. We're going to identify the terms, like terms, coefficient, and constant terms of the following. Okay, so here we have two terms. We have a 5x term and a 10z term. Our coefficient on the 5x term is the 5, and our coefficient on the 10z term is the 10. None of these are like terms, and we don't have any constants here either. Okay, next, we're going to identify the terms. So we have one term here, two terms here, three terms here, four terms here. So we have 1, 2, 3, 4 terms. Here's the first one, second one, third one, fourth one. Notice that terms are separated by plus or minus signs. Anything that's separated by a plus or a minus sign is a term. Now, let's identify the coefficients. The coefficients on this term here is 4. The coefficient here is 3. Coefficient here is 2. Now be really careful here. Notice that there's an a down here, but there's no number in front of it. The coefficient of that is a 1. When there's no number, it's a 1. I'm allowed to take term 1 and term 4 and put them together because they're both a's. So we have 4a and regular a. Those are called like terms. Since this a is a variable, it's not a constant. So again, we have no constants in this expression. Okay, let's separate our terms in number 3. And while we're doing that, let's identify some like terms. Here's a 7. Let's look for another constant. Ah, there's a 2. Let's circle those so that we know they are like terms. Let's put a squiggly underline under the u's so that we know they're like terms. And the 13n is sort of by itself. It doesn't have another like term to go with it. The coefficients of our terms are 13, 5, and 9. There are no coefficients on constant terms. They're just constants. Okay, let's go to the back. On the back, we're going to do a little bit of simplification. And to do simplification, we're going to put together the stuff that looks the same. So in number 1, we have 3x plus 2 plus 5x. Now notice that the 3x and the 5x look the same. Why? Because they're both x's. So we have 3x plus 5x, which is 8x, and then the 2 doesn't have anything to be added with, so we just write it down. Don't try to turn this into 10x. You can't do that. X's and constants cannot be added together. In problem number 2, we have b's and we have constants. I like to identify my like terms with circles or squiggly underlines or even sometimes X's through them if I run out of symbols to use whenever I have more than a few like terms. Negative 7b plus b, that's negative 6b. And then 3 minus 10 is negative 7. So remember, these two came together and formed that right there. This and this formed a negative 7. Let's try 5 plus 8w minus 6 minus w. The 5 and the 6 go together, and the 8w and the w go together. 8w minus w is 7w, and 5 minus 6 is negative 1. All right, let's go to the bottom and simplify expressions with some parentheses. Here, we'll have to do a little bit of distribution. So we're going to use our skills with the double bump or the Santa Claus hat to sort of expand this out a little. We have 2 times x, which is 2x. Then we have to come back and get 2 times negative 4, negative 8, plus 9x, plus 1. I just recopied down everything that I hadn't used yet. Now, what I need to do now is put together everything that's the same. I'm going to draw some circles around my x's, and I'll draw squiggles under my constants. 2x plus 9x is 11x, and negative 8 plus 1 is negative 7. That's as simple as we can go. Our next one is 3k, which I'm not going to do anything with yet, and then a negative 8 times k plus 2. Here is some distribution here, and I'm sort of running into my answer from the previous problem. We have negative 8 times k, which is negative 8k, and then negative 8 times 2, which is negative 16. 3k minus 8k is negative 5k minus 16. Here's perhaps the trickiest one we're going to do. Notice that there's a 4a here, and then a minus sign with no number here. Well, just because there's no number there doesn't mean there's no number there. It's a 1. This is a negative 1 that must be multiplied through this set of parentheses. So we have negative 1 times 4a, which is negative 4a. And then we have negative 1 times negative 3, which is positive 3. 4a minus 4a is 0a, or 0. So all we're left with is the 3. What I would like you to do is try these bottom 3 problems on your own, and that's where we will start this lesson in class. If there was anything that was confusing or you didn't catch something, make sure you go back and rewatch that section of the video.